Hello, I'm Greg. Welcome to my channel, Midnite Oil Software, and another lunchtime live stream. I didn't live stream Tuesday. I was working through lunch, and then yesterday was my weekly mastermind meeting, so I did not live stream then either. So today I'm going to get back to what we were working on in my previous live stream on Monday. If you watched it, you'll know that I used Bezi, the AI coding assistant, to try and design and implement a floating origin system. So an issue I have in my 3D space shooter game is if the player ship gets too far from origin, you start to see jitter in the rendering, and it can also break physics down over time as well. So one of the proposed solutions for this is to use what's called a floating origin system. So as the player ship gets far enough past a threshold beyond origin, it will shift all the other objects in the world, including the ship, back towards origin. So now nothing is too far from origin to render. And of course, this would have to be further optimized in the future, especially in a multiplayer game where we maybe would queue up objects that are outside visual range and then shift them, you know, on other frames and stuff, so we don't have a ton of network traffic when these things are moving. And we probably want to put in occlusion culling and other optimizations so that we're not really slowing things down. But when I tried to implement the design that I came up with, which was, I thought, a pretty good design, it didn't work. And if you watched the live stream on Monday, when I was looking at the code that Bezi had come up with, I was skeptical about it because it's basically searching through the scene for all the objects that need to be shifted every time it's doing a shift. And I realized looking at that that's unreliable, and it's also not very performant. And so what I've done is I actually told Bezi that I thought this was brittle. Well, first of all, it's not working. Bezi, in addition to implementing the shifting algorithm, it also put in some GUI buttons, debug GUI buttons onto the game that I can use to jump 10,000 units from my current position to see if it automatically would do the shift and everything. And it was not shifting the player's ship, and I was very quickly getting jitter because I was too far away from origin. So with that in mind, I told Bezi that I thought that was not a reliable approach, and I suggested an alternative where we have a component that you could put on any object that could be shifted, and it could register with the floating origin manager, or whatever we're calling it. They could basically register themselves with the manager and then deregister themselves. That way the manager doesn't have to go look up anything. It doesn't have to go find what objects do I need to shift. It already knows because they registered with it. And also the player ship is going to have a component on it that's basically a floating origin reference or something like that. It's basically the reference position relative to origin to know, has it gotten far enough away that we need to execute a shift, and then how much do we need to shift everything. The other benefit of this is when we do add multiplayer, every player ship that joins the game can register themselves with this manager, and we could do a, forget the word, a centroid, basically a centroid calculation to kind of take their offsets and take the center, basically the averaged offset from origin, and shift things based on that. So all of this is going to position us better for when we add multiplayer. So I gave that prompt to Bezi and told it to update the documentation that it had created, which was, you know, the design for implementing this pattern. I told it not to make any code changes yet, but just to update the documentation. And it did that. And here is the summary of the refactor that it came up with. It described the problem with the old design. And, you know, it has to find every object, every shift. It's easy to miss object or shift wrong ones. It's expensive. It doesn't handle special cases well, and it can cause jitter when objects aren't properly synchronized. And it makes it difficult for multiplayer support. So anyway, I had to come up with a new design where there's going to be a shiftable floating origin. This is a component we can put on any object that can be shifted. And there will be a base class, and from that we'll derive ones for rigid bodies, particle systems, and trail renderers. And then for the player ship, we're also going to add this floating origin reference that will also register with the manager and unregister as player ships are destroyed. So it's going to have to refactor that floating origin manager to add this registration API. It's going to maintain a list of registered objects, and it's going to do a centroid calculation that will be multiplayer ready. So if there's more than one player ship on there, it's going to do that calculation. And everything else is going to pretty much remain the same, except it's not looking up the objects every frame, every time it does a shift. And that's going to have multiplayer benefits. And then it gives me the migration steps for what I need to do to actually implement this new design. And speaking of design, I want to jump over to GitHub, and I had it generate a system architecture document for this new refactored design. And so it describes the key principles for this. Players, enemies, asteroids, they all shift at the same offset. The spatial relationships are preserved, so their distance from each other should remain unchanged. It's registration based, so objects explicitly opt in to participate in shifts. It's event driven, which allows for loose coupling. And it's multiplayer ready by supporting centroid-based shifting for multiple players. And this is basically how it describes the precision loss when you get farther away from origin. This is basically what happens. You get minor jitter, visible jitter, and then physics breaks down when you get a certain distance from origin. These are the symptoms you can expect. And here's the solution. When the player shift travels beyond a threshold, and this threshold is configurable in the Unity editor, we will calculate an offset. We will shift everything by that offset, preserving all their spatial relationships, and we will continue to track that absolute offset in the origin manager. So before and after the shift, it shows you basically here's the player, here's this asteroid, here's this enemy, here's where origin is. After the shift, this is where everything would be, and they're still relative to the other objects by the same amount, but they're all basically relative to origin by a much less amount, which should reduce jitter. This is the component hierarchy that we're proposing. We're going to have this base, we're going to have this floating origin manager class. There's going to be a vector 3 double we're going to use to track the offset. We're going to calculate the centroid using these floating origin references, which will be registered with the manager. These are only going to live on player ships. And then we will have these shiftable floating origins with their derived types for rigid bodies, particle systems, and trail renderers that will actually be shifted. And then I have a diagram here to describe. Here's your origin manager. It manages references to the floating origin reference. It manages the shiftables through their shiftable floating origin classes. It calculates the centroid offsets and averages the position, detects that the player ship is beyond a certain threshold, performs the shifts on all the shiftable objects, and keeps track of the absolute position. So anyway, this is the overall design. There is a shift flow, which is pretty self-explanatory. It's basically a sequence diagram. The player ship, I'm explaining here why I need both the reference and the shiftable component, because we need to tell the manager when we need to do a shift, and the player shift itself also needs to be shiftable. I go into some discussion about the difference between single player and multiplayer, and that's basically how it's going to do the centroid calculation. The data flow, this is basically a flow chart showing how that's handled. For some reason, this Mermaid diagram will not render correctly. There's an error in the syntax that Bezi generated. I can have Bezi go fix that, but that's not a super high priority right now. I have my component lifecycle diagram, the player ship lifecycle diagram, performance considerations. So basically, by using a registration, instead of having it look up everything, every frame, we're going to have a huge performance improvement using this new approach. And I talk about how I use the event bus in this system and how I have this example event listener where people can subscribe to that shift event and handle that. So the key takeaways from this new design are listed here, the architecture benefits, and so forth. So jumping back into Bezi, I am going to create a new chat thread, and I'm going to have it look at my refactored design here, and I'm going to ask it to implement the refactored, if I can spell, refactored floating origin system according to the specifications in the floating origin refactored design page. And let's see how vibe coding can, well, let's see if Bezi and vibe coding can actually refactor based on this updated design that we've come up with. Oh, great. So apparently I updated Bezi and I need to update the plugin in Unity as well. This shouldn't take long. Sometimes when I do this, I lose the connection between Unity and Bezi, and I'd have to restart Bezi and or Unity. Sometimes I'd actually have to reboot my machine. Hopefully that will not be the case with this update. So if you just joined us, I am installing the update for the Bezi plugin into Unity, and I'm going to have Bezi try and refactor my floating origin system using a new proposed design that I came up with in between my last live stream and today. I need Jeopardy music to play. Okay, let's jump back into Bezi. It looks like I've got a connection there. And it looks like it's going to try and do it. So it read the design specifications. It's checking the directory structure. It's creating the refactored implementation according to the design, creating the necessary components. It's giving me my shiftable floating origin base class, my floating origin reference, my shiftable rigid body, shiftable particle system, and shiftable TrailRenderer. Now it's refactoring the manager class to add that subscription API and the centroid calculations and all that. It's verifying to make sure it compiled correctly. It's updating the README file. This is the README here. I'm guessing that's the README it's talking about. Oh, it's actually updating a readme.md file, it looks like, under the scripts folder. Yeah, it is. You know, one thing I haven't checked is to see how well Rider renders Markdown. Let's go down here to Project, Scripts, Floating Origin, README. Pretty good, actually. Very nice. It's updating my refactor summary. So using these pages in Bezi, it serves as a memory bank for your model. It keeps track of what it's already done and whatever is left to be done. So it really helps you with future chats. You can just reference those pages and you'll get a much more accurate result from it. Yes, there is a runtime error when I stop the game where I'm trying to delete the timer manager or I'm actually probably trying to delete or unregister a timer from the timer manager because the timer manager is gone at that point. I just need to put in a check to see if the timer manager is still there before I try and remove a timer from it. Implementation complete. Next steps. So I need to update the player ship prefab. I need to add that floating origin reference and the shiftable rigid body component to it. I need to update all the asteroid prefabs to add the shiftable components to it. And I also need to update other objects like the explosions, projectiles, and things like that. I'm going to say go ahead and keep all. I probably should have reviewed the changes, but as I mentioned in previous live streams, all this stuff is under source control, and I can just discard these changes, or I can even just blow away this whole branch if I break anything. Okay, so going back into Unity, let me go to the player ship prefab. And I want to add a floating origin reference. And go ahead and minimize that. And I want to add a shiftable rigid body. That's the one I want. And we have the rigid body right there. Okay, so that's good. I need to add those to the enemy ship, but I only want to add the floating origin or shiftable rigid body to it. Let's go into effects, and I'm going to go ahead and add it to all of these. I think that's what I want. And then let's see. The TrailRenderer. I wonder how that's going to be handled since the TrailRenderer is a child of the player ship. And it's actually, I think, on the engine. Yeah, it's on the engine, on the thruster. So this whole thing should shift with the ship. I don't know if I'm going to need to add another component to this guy separately from that. I'm going to test it without it and see what happens. Let me go look at the weapons. So we have our projectiles. So I want the enemy missile, an enemy projectile, missile, all of these guys. I want to come down here, add component. I think I'm going to want that one. Okay, what else did it say was on the next steps? Oh, the asteroids. That looks like it will be it. And the one thing I'm really curious about, if there's anything on my Floating Origin Manager that will display, let me see the registered objects in the inspector. And it doesn't look like there are. So I'm going to go ahead and ask Bezi. Actually, I don't need to ask Bezi. I'm just going to go into my managers. And I want to add a show an inspector. You know what? That might actually only exist if you have Odin. Oop. Why is that redundant? I'm going to leave it there anyway. I might not be able to see those. I might have to add a public getter that just returns a copy of that list. I just want to be able to confirm that what is in those collections is correct. Yeah, I don't see anything in the inspector regarding items being registered. Okay, so I want to jump 10,000. So I'm currently very close to origin. Oop, it shifted me. it worked. And it looks like the asteroids must have shifted too, because I'm the same distance from them. So is it working? I think it must be. Okay, so let me go back into Visual Studio or Writer. I'm going to get rid of these. Registered shiftables count. Well, I can definitely look at the log. Okay, on GUI. Oh, good. So it does show me how many objects are registered. So let me go look at that again. I got my total shifts, absolute offset, centroid distance. And let me go look at the log. Let me enable debug log on the manager. And run this again. This time I'm going to, well, I'll change to maximize after I do it. Okay, so there are 2,603 registered shiftables. There is one registered reference. Now, what was that explosion from? I have no idea. But let me jump. Total shifts 2. Because I jumped 10,000. Total shifts 4. That is awesome. That is awesome. Okay. Ooh, got a particle material problem there. Something about that explosion prefab that it doesn't like. Something in the material. Okay, but that is a problem for another day. As near as I can tell, that refactor of the floating origin system worked. So dang, I got to give Bezi props. Absolutely got to give Bezi props. I'm going to go ahead and save project. And I'm going to go ahead and commit those changes to source control. First, I'm going to have GitHub Copilot give me a commit message, a description of what was changed. Wow, it's really taken its time. There we go. Introduces new editor utilities for managing floating origin components via menu items and adds core scripts for shiftable and reference components. Also updates several prefab material assets and modifies a TextMesh Pro. Okay, that is not sufficient. Implemented the floating origin system to prevent jitter when objects get too far from origin. And I'm going to go ahead and commit those changes. What? Okay. Let me just stage these. They're already staged. All of those are meta files, and, well, there's a prefab. Oh, there's scripts in there, too. I don't know why it didn't commit everything. Oh. There we go. Yeah, I don't know why those files weren't selected before. Go ahead and push those to origin. Sweet. So now if I go back to my GitHub and I just come up here under assets and I go down to project, scripts, floating origin, and I look at that README file. There's the README file for the floating origin system with the latest implementation. And I also, I believe under assets, floating origin implementation, floating origin architecture. Yeah, so that document is here as well. So I love that you can put these things directly in your GitHub repo and they will render fine in the browser, even with your Mermaid diagrams, which I love this instead of putting images in because I can modify the Mermaid syntax underneath of this if these change. I don't have to regenerate images. So I love including Mermaid. I'm going to have to get it to fix this. Watch how quickly Bezi will fix this. I'm just going to create a new thread, and I'm just going to say, fix this error in the Mermaid diagram. And let's see, that was in assets floating origin architecture. Assets floating origin architecture. So I will paste that, and then I will paste that. And let's see what Bezi does with that. So it identified the error. It fixed it. I will say keep all. And just to make sure, I'm going to go into Writer. And under Assets, I'll look at that. This doesn't actually render the graph, so that's one thing Writer does not do. So I'm just going to go ahead and commit this. Push it. Go back into GitHub and refresh. shift calculation flow. That was it, wasn't it? So it fixed it. I'll tell you what, man, you can't beat Bezi for documenting code and creating architecture diagrams. You just cannot beat it. Now, you can beat it. I mean, you can match it. If you have GitHub Copilot in your Visual Studio Code, it can see your entire project and it can generate similar documentation. So you don't need Bezi necessarily to do this sort of thing. I just find the integration with Unity to be so useful that I just really love using Bezi. But anyway, this was a fairly short and sweet live stream, but it was a very profitable one. I was able to use my Bezi AI coding assistant to refactor my floating origin system and get it actually working using my proposed refactor design, which is a registration-based system, which in my opinion is a heck of a lot better than what it came up with initially. But anyway, if you enjoyed this video, click that like button, subscribe to my channel if you want to support it, and also click that notification bell if you want to be notified the next time I go live or post a video. And if you have any questions or comments, join my Discord server. There is a link in the description, and I always am on the lookout for comments there. If you have any questions in particular, you can paste code snippets and whatever, and I'll do my best to answer them. Thanks so much for watching, and good luck on your game development journey.